begin. So the challenge. Unix has never been very visual, but we do not want to change that. It is perfect as it is, and one can stack whatever visual things they want on top of it. So that's not in question. Standard I/O is brilliant. That means you can pipe utilities in one another and increasingly add features in seconds, which I challenge you to do on any other operating system. And it's a fundamental tenet. I do recommend the book, The Unix Philosophy by Mike Gankar's. Very good about just why these things are like that and why we don't want to change them, bolt too many things on top of them. So, to say the obvious, one can pipe commands together. And
useless use of code.
Thank you, sir. We have resident heckler heading power here. Welcome, welcome. So, the challenge is that we are visual. There are very rarely visual cues. Let's see, here's the system building world. It gives you a shell prompt. Here it is busily mapping the human genome, shell prompt. And here it is saving. And occasionally the utility has a visual feedback like green or red when something's going well. But typically those are accommodated with captive user interfaces, which is unfortunately violating another fundamental tenet. So, for example, top will give you a dump option, like a batch mode, and at least provide all that for you to parse later, but I find that limiting. And if you know what to look for, you can see that occasionally there's some activity to be concerned about or pay attention to. So again, we are visual. I went all out on graphics here in the school per hour here. So what options do we have? So we don't want to switch to a Windows-like captive visual interface. Don't want to go down that road. And again, many of those utilities lack batch mode or scriptable mode where you can at least get a dump of its output and go from there. When it comes to, say, performance tools like anything to benchmark network performance out there typically has a captive console interface, and then occasionally other options over the wire. So it's also the question of time. Following and benchmarking any system is a bit like following your drive to work. If you take your snapshot in time of you backing out of the driveway, you'll have this terrible, terrible performance metric. If you catch yourself on the highway, it might be quite good with quite good efficiency. So things can differ between a very short amount of time. And so it's a question of how do we accurately represent something over time without constantly ourselves manually grabbing those samples. So again, your drive to work is overall something you want to graph, but perhaps any moment in time might not be too attractive.
That's a very nice set of viewpoints.
Yes, sir.
You're not taking the metro.
What metro? From Los Angeles. I don't know that word. So, I found this tool useful, and maybe you will find it useful, and I'm happy to help you extract information you want with it. The tool is Graphite. It's at graphite.readthedocs.org. They have kept the previous site up, which is very confusing because you will often find it. Wiki something, wiki dot or thereabouts. And what it does is to store numeric time series data and render graphs of that data. Now, key point, time series. You are constantly checking it. And good old days, I don't turn the slide on it. I can ping it. It looks great that moment. Not so useful. So my personal philosophy, go with simple, hopefully followed by simpler. And I don't like moving parts. I want a bare minimum system to achieve what I want. Hope that's in compliance with a Unix tenet. And in the words of researcher Daniel Gear, the essential enemy of reliability is complexity. Anyone agree with that in this room? Excellent. So, objectives. And I will follow these slides pretty closely for those who are reading along more than following in English. So, operator-driven. I don't want to be relying on upstream projects to produce tools that might be useful to me at some point and are hopefully useful on arrival. So you know your network best. Your objectives change. Your objectives or your boss's objectives might be different tomorrow. So you need to be nimble. And typically you needed it yesterday. And I trust that someday there will be a great Bhyve and expanded ZFS plugin for, say, collect D and many of the popular statistics daemons, but I can't wait for that, I'm sorry. So it should be easy to use. I am not an advanced programmer, but I need the tool regardless. And there was a time that once you set up a new network daemon and say, hey, I can ping it, and go off to lunch and call it good, but it doesn't always cut it. And furthermore, we're working in a unified operating system. We have great resources at our disposal. If you want to store a file, try one of the many awesome file systems available to you. Don't necessarily drop it into a database on top of the file system. It may not be faster, it may not be easier to find. So embrace that OS whenever you can. Leverage it. And I'll a little later touch on questioning some of the traditional behavior, some of which hasn't changed in 30 years. So, also, something I discovered is look at things like the real-time clock. Fortunately, Kirk yesterday described some of the real-time features in FreeBSD. And when you're, say, plotting things, megabytes per second, and you start running time on the wait command, and a second varies in length, you have to wonder about how accurate is this data and how long a sample do I need to get something that is statistically accurate. Kirk pointed out that there are kernel averaging counters that are delivering what you see. But the fact that the kernel's handling it is also an opportunity, so we'll get to that. So, and over the years, Unix has changed. We have specifically 3 stunning technologies, 2 of which are very well represented in the room today. Packet filter, which comes out of OpenBSD, ZFS, which comes out of Solaris, and Bhyve, which comes out of technically NetApp, and Peter Green is here this week. And I've been focusing most on that last one. I consider it quite stunning, and I hope some of you made it to BhyveCon the other day. And yeah, what took you so long? I've been using Unix since January of '91. There was no Linux, there was no FreeBSD, there was no OpenBSD, there was BSD or AT&T, and it was clear that some of it's very awesome, but it's missing key components, and they finally arrived. So we have diversity. Back in the day, there was AT&T and BSD, and then some experimental work, Unix and debates over, well, is the author taking in patches to make it a truly open project, because it's supposed to be research, but it is useful, so maybe we make more with it. We have Linux. We have the various BSDs. We have Apple's Darwin. Love it or hate it, it's on a lot of devices, and it's using a lot of these technologies. It has packet filter hiding in it. It briefly had ZFS. Just this late last night, I saw an announcement of a new ZFS on Mac talk website with various download links and forms and all that, and they're making headway using the open ZFS project. And so, as the open OS research is dead, but there's still Linux out there. There's still various other operating systems and opportunities there. And back when I first used a computer, you had to choose between Mac, DOS, Amiga, others. And the moment I made a choice, I wanted to see how the others behaved. But that would be a costly endeavor. But now with things like hypervisor, that can be seconds away to try another operating system, try the same script on it, try a different version of the same operating system. And we have mature open source. There is no going back. If you could try to sell Google on the notion that maybe you can pay a per CPU license of $1,000 and then a user access license of $100 per user, or each of those, what, billion now Facebook users paying 100 each, the model falls down promptly. And for all that money, you could write a completely new operating system from scratch. So, and hire the best people available, which is something I finally clued up to, or embrace the community and leverage the community. So, key point, multiplicity achieved. I guess it's been about 5 years I've been giving talks at the BSD cons about various multiplicity virtualization technologies on the BSDs. And there was always something missing. It was always like, we're not there yet. Zen is promising. The license isn't quite right. And it's almost there. It's very reliable on NetBSD for what it's worth. I almost consider that a best kept secret. That served me very well, but still, I'm very pleased that we've added to jail Bhyve, a hypervisor. You can read more about it at bhyve.org. I won't go too much into it today, but you can ask me individually, and again, Peter is here at the conference. So, such technologies are proving very useful for containment, for prototyping, development. I predicted last year at this conference that if you're developing anything on FreeBSD, you'll likely be doing it in Bhyve within a year, because if you're, say, doing, at the time, FreeNAS work in FreeBSD 8, if you want to bring it up on your 10 laptop, you can do that within minutes or seconds if you script it right. So that kind of stuff makes me very, very happy. And by introducing those tools, you get a whole lot of layers of depth to consider and analyze and look at the interaction of these components. Because once upon a time, things were very flat. There was the disk, the set of users, the one of everything, the one CPU, but now we have multiple cores. We can have dozens of virtual machines, and that was one of the key motivations in these tools, is to find ways to find out who's doing what among all those tools, all the components. So opportunities, it's now very simple to routinely run say GNU Linux on FreeBSD. That can be done, and there are those in this room who are using it in production and proven that it can be done. You can run BSD on BSD, you can run OpenBSD on FreeBSD. And I believe out of the Open Solaris, perhaps even back in the Solaris Day camps, they put their zones, let's see, move fast forward to, I think, Joyent. They're putting KVM within a zone, such that if one were to exit the hypervisor, they'd be contained in a jail, essentially. So there might be opportunities there in this stack. And in all of this, with these tools, we can do some assumption testing. It's like, well, is ZFS slower than UFS? And many would say, oh, well, yeah, everyone knows that. In certain, there are ways to get around that. I'm not knocking ZFS in any way. But I want to see what that means. I want to see it. As I say in Arkansas, it's best you show me. So, for example, FreeBSD now has its own in-kernel ICE50 target. Well, which is faster? Let's make answering those questions real easy. So, lessons learned in this whole process. All of the BSD installers are designed to be used every 2 years when you get a new machine. So if they're painful, it's not a problem, because you'll be done after spending your afternoon getting the exact partitioning to work and finding out the BIOS doesn't work with, say, GPT and all that nonsense. And so in the course of this, I have had to essentially produce my own installer, which breaks down the whole process from partitioning a disk to making it bootable to dropping a file system on it, which the basics of which are very simple, and I've been doing that since like 2005 with jails and disk images, and so it can be done, and kudos on that to the BCBSD folks, because it's a very end-user oriented installer that asks you the questions that matter. It allows you to have, say, an OEM boot and create your first user on the first boot, and that's progress, and I want to see more of that. So, key lesson, script everything, and script your scripts, and once you've done that, you find that with a library of, say, installation functions, you can then create test machines in seconds. If you want an oddball file system configuration, it's just line it on up and repeat it often. So the hands-on installation of what I will be describing is in the proceedings. I will make that downloadable hopefully within the next day or so. It's been evolving rapidly and improving. And also the basics of the telemetry generation is also described there. And contact me if you want to try anything out because it's rather easy to deploy. And so first, the environment. I had never used much of Django, short of through the FreeNAS interface, just as a user. I had not done much with Python. I had not done much with Git, so I just went directly into the simplest installation possible, just to keep it manageable. There's a great many sources of documentation out there, all of which are tailored to that one use case by that one developer. So I've pared it down to the absolute bare minimum such that you can reproduce it and customize it as you see fit. I've ended up just using the official Git checkout as suggested by the project. There are ports out there for the various components, but they were broken when I started this process. They've been updated, but still they're tailored to specific uses. They're very simple, so Python-oriented installation steps. Unfortunately, these are generally nicely contained away from your host system, so you shouldn't worry too much that you're not using packages that are easily removed. I've gone with the default /op directory that you can easily delete, which is good. So, just for a taste of this, rather than actual documentation you should take down, it's all scripted in the proceedings, but package install the various components that are needed for what I'm doing. Many are just for the rendering tmux to make it all backgroundable, and various Python tools. I hadn't used pip, but it's a simple, yet another installer of software, as if that's not a solved problem. Graphite itself includes a bunch of default config files that generally work out of the box. However, they're given a .example ending, so you have to bring those into the right position to work. And those are all covered in the installation. And this isn't necessarily a talk about Graphite itself, but it's a graphing tool with its own collection engine, a bit like collectd, and its own storage database called Whisper. So a key thing when we're making this work is to simply get the Carbon daemon working, ready to collect information, which is a very simple start or stop, and start the graphical web server. And one could push these over the wire to another machine such that all of your, shall we say, client machines are pushing telemetry to a central host. One caveat, the Python community is very, very fond of clever names. And if you start searching for Graphite, Whisper, and Carbon, you will get a lot of golf clubs. You will get a lot of tennis rackets. Whisper, Quiet, Graphite, and I suggest they come up with some universal keyword or ending to distinguish it. If you look for Python, you get lots of pets. And just consider yourself warned. So, telemetry. This is system information, and the stuff you typically pipe to syslog or otherwise, or Nagios, etc. And in the spirit of simple, one can test the collectd functionality by simply running netcat listen on port 2003, and that'll drop the responses to the console. Very, very simple and useful when testing all this, because if you haven't used all these components before, the documentation isn't always clear about how they should perform, where they belong, and all that. So, collecting information. Again, the goal is nimble. The goal is rapidly prototypable and changeable when your boss says, no, 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 the marketing department now cares about this. So I'm working with in-base tools, some very simple parsing. There are generally better ways to parse any one thing. Do whatever's most comfortable for you, whatever If it's a whole lot of piping, go for it. If it's a one-line op command, go for it. So the traditional tools that I mentioned are somewhere between batch-oriented by not having captive interfaces, yet aren't necessarily for raw parsing and don't put out just a value, but we'll get to that. So extracting those values is generally not very difficult. And again, we can't wait for a plug-in for another project that could take months to appear, whereas there can be very simple solutions. And in looking for, say, bandwidth sampling, there was a suggestion of install Nagios. And well, the in-base tools generally provide you the raw data you need. You sample it once, you sample it again after a set amount of time, and give an answer. And that's typically what all those big tools are doing, as Henning has confirmed. So you may end up essentially with those fancy tools running something exactly like this. So if you can ditch that 100,000 to 1,000,000 lines of code to get the same effect, I'd go with the simple one. So sending it over the wire, you can encrypt this however you please, but I'm doing a simple netcat send to a port over TCP/IP. You can also do it over UDP. Just make sure Carbon is listening. And here, behold, is the heart of the entire Carbon Graphite data collection system. A human-readable name that's separated, but I believe you can even truncate that down to 1. There is your metric, which is just a number, 35 or 35 whatever's per second, whatever you choose, and a Unix epoch date stamp. That's it. So, the framework to make all this yet easier has involved me provisioning virtual machines in Bhyve. I don't know if you've been following all that, but that's ended up with, say, a scripted installer that's just all the functions to make a file system drop on disk and populate it with off-the-shelf distribution sets, etc. Managing those through an RC script, so it's very Unixy rather than a captive web cloud interface. And then the tools to generate load, just as I described. So, I'm happy to sit down with any of you and just show how I'm provisioning machines. And if there's time, I'll give a little demo with a certain tool that can work either captively or take some basic parameters, work from a template, and say a custom name. And with such things, you can go to town on how personalized you want it. But with Unix, there's generally the stock way of doing things and then custom ways. And so, again, about the RC script, I have gone with a just very off-the-shelf, in this case, FreeBSD RC framework to start, stop, status, load, unload, and various mount, VM directory, etc. But get into that in another talk. Status of running machines, attaching to a virtual console on a machine. Very straightforward stuff. And so, again, in the proceedings, it's the install script, but I can provide that to you if you like, or I'll have it online shortly. And once a guest has this one non-interactive script run and has it ready to receive that is Carbon daemon started, one can start sending telemetry. And for example, a very primitive network traffic generation is to perhaps send the yes command over the wire. Just say, here's some raw data aimed at that socket. And listening on that port, dropping in dev null. And then with just 2 lines, you have some various things to work with, and you can upgrade that to, what's the popular point-to-point traffic tool? I forget, but anyway, lots of opportunities there. So with these tools in place, let's talk assumption testing. Okay, UFS writes faster than ZFS by some amount. And if you just sit down at your system and occasionally just randomly snapshot it, you might catch a disk while it's realigning its head or something, and your metrics might be all over the map. So when running these tests, are you testing a file system or a device? If you're using DD, are you aiming it at a file system or a raw device? They may perform very differently. And for example, does a given file system change its behavior depending on how full it is? So, this was me running over 5 minutes rather than a 1 moment snapshot in time. And in blue, we see what I have running in the background is a simple script that, okay, first the setup script. I've created 2 malloc devices such that we are not testing a hard drive, we are testing hopefully a raw file system. I have 2 RAM disks, one of which is partitioned UFS, one of which is partitioned ZFS, and I'm using a DD command to put in about 1.9 gigabytes in a 2 gigabyte destination. And it will run one of those, run the other one. Run one, run the other, and I go get a cup of coffee. So here we have UFS writing, and looking at the DD output, use whatever tool you want, but I use DD. It'll generally bring, I don't have the exact numbers, about 780. And looking at ZFS, pulling in about 330. And there are many ways around that. I'm not knocking the file system, but I wanted to explore that common wisdom that everyone knows, but I've never seen a number associated with. So by starting as simple as this, you can imagine all the different ways of trying different configurations. Trying thin provision in memory, various Z pools, different multi-device configurations. And starting with hello world opens lots of doors. Starting with a comprehensive solution is generally very frustrating because one size fits none. So, I didn't graph this too much over time, over filling up, but let's see if we only put in 75% of the capacity of a given target. Well, the results were actually about the same. I was surprised. There are many strategies to optimize from the sources to improve ZFS as it fills up in capacity and maintains its performance. So it was something I've heard. I want to see it. I just want to see it. And again, not knocking any technology, but I want something quantified to go with those statements. So again, the simple math on testing anything blah blah per second. Well, sample it once, sleep, sample it again, do some simple math. And here I'm pulling out the iBytes as reported by netstat. Just grab it, sleep, grab it again, do some simple math. And again, as Kirk explained yesterday, the kernel is doing its own averaging. You want a certain amount of time, and he quantified that too. Probably a minimum of 15 seconds to get a good statistical sample versus me with my second that takes various amounts of time to be a second. And then if you're thinking something's per second, well, your mileage may vary. So on Bhyve, looking at VM exits, and it does have debugging tools that allow you to see various statistics on machines, and having one number that's simply growing is not very exciting to graph because it just increments. So I've worked that into exits per second and following the exact same few lines of code. And once you have those in place, it's quite easy to get more complicated. So the classic FreeBSD metric, the build world, initially had lots and lots of VM exits. And then surprisingly, let's see, exits, the Bhyve process would eventually hit at times 100%, not be graphed too much. This was pretty quiet. I didn't have anything going with, I guess host CPU load was just off the top writing along. Actually, it reported low, the Bhyve process reported high, and with the simple little tools in place to capture that type of stuff, you can build up and customize as needed with very little effort, especially for late night sysadmin like myself. So
what are VM exits?
that is when the hypervisor is, I believe, asking for its own personal memory, and the extended page tables are saying, hey, okay, let's remap to your proper one, rather than just a, I guess, user process that wouldn't. That's a very good question. I'm not one, I thought Peter would be here, and he's good about that, but that's the key question of when the virtual machine is asking to have privileged access. But let's sit down and corner him, find out what this is based on his suggestion, what to map. But yeah. So packet filter follows some of the same logic on the PF log device. That's a whole conversation we can have. On ZFS, the collect D does have its L2 arc monitoring. Grabs a few items. As you may know, running the ZFS command will give you a whole lot of information that you can work with. And there are quite a few utilities. I believe Martin's giving a talk at this conference that's on some of these utilities. It was an impressive talk in Warsaw. So lots of opportunities there. If you're familiar with Shell, many are Shell-oriented, many are Python-oriented. And for those who still have spinning Rust, there's the Smart Mon tools, and it provides you a whole lot of information in a captive way, and things like asking for your temperature, or the important stuff, your serial number, your temperature, and the warnings of impending doom. Generally what you want out of all that information. So that raises a question I touched on earlier, which is questioning these utilities at a fundamental level. My working informal term is the get utilities. ZFS has been great about get this from that pool, get this one piece of information, and kindly -H to have no headers to make it more parsable, and requesting specific properties. I believe it will give you an actual numeric value, and with that value, we can send it anywhere. We can simultaneously send it over the wire to a Carbon daemon. We can log it ourselves. We can drop it on a web page, whatever you please. So I would like to see more of, say, SmartPixel get temp dev ADA0. All I want is a temperature, and I'll take it from there. This is very easily prototyped with captive little utility that is performing various regex depending on what you put in as the first command. And we again are working with a unified operating system. Hopefully, any given utility was written in compliance with the coding standards of the greater operating system. Hopefully it has an elegant library that it's calling. Hopefully, when it simply says, here's what a sysctl said of what's going on, we can link to that same library, crop out all that other stuff that reports other nonsense, and create a dedicated utility for our one purpose. Because there are many complaints, oh, you're using scripting, that introduces overhead, etc. Well, you can follow it down the Unix stack from shell to C to assembly if you really want. And all those resources at your disposal. So let's hope the various authors of these tools have been disciplined and are perhaps open to opportunities like get commands. Along those lines, Alfred Perlstein has suggested something called Eagle Eye. I believe he was proposing to put out XML and other parsable formats from those tools. Wouldn't help me because I just want a numeric value. I know what to do with it. Doesn't need to be prefixed as this is your temperature in brackets. So that would put us back where we are, but it's indeed someone questioning how can we make this more simultaneously human-friendly and machine-readable. Future directions. This is all intended to be graspable to pretty average sysadmins who are, you know, they are scripting the moment they run the script command and catch everything they're typing. So scripting should not be too intimidating. And I think everything I've shown here is quite straightforward and simple. I found that it's a bit of a gateway drug. Once you are trying to find out, say, how long a second is, you become very curious of what it's indeed doing to generate that. When you see that a utility is printing out the value you want, but is suffixed by a K for kilobytes, and you have to rip that out, but you know that there's a print statement somewhere in that code that simply adds a K, and you just need to delete it, and that's not an advanced programming step. You get tempted to look under the hood. And again, it's all intended to be very flexible. Useful in all this are disposable virtual machines. I discovered jails specifically trying to get LAMP stacks contained so you can delete them in one fell swoop rather than look at all the shared libraries and figure out who's out of date, who's broken, who's doing what wrong. But with Bhyve, you can have a genuine, unique kernel running in front of you for the few seconds it takes to set it up and the few seconds to interrogate it and the moment to delete it. That's huge, huge progress. And they multiply this opportunity, and there's some unintended there, but I hope it's clear that with such an approach, you can be very flexible. Capture a metric that's human readable, convert it from bytes per second to megabytes to make it even more human readable as needed, and then drop it wherever you like, be it into something that happens to go to the web interface, be it your own logging tool, be it presentation slides. And so let's hop into a demo if there's time. That's the heart of it. I have dog-fooded this with PCBSD at last year's conference. I said it would sure be nice to have a FreeBSD 10-based graphical OS so I could run Bhyve and pretty slides simultaneously, getting away from ASCII art slides. So it is now 10 o'clock. Should we do some questions and then get into a demo if there's any time left? So, questions? Yes, sir.
How often did you run into the problem where utilities gave you back information human readable with like units and 1,000 separators and things like that?
Virtually all of them. The question was, how often are utilities generating, helping you by adding, say, suffixes on megabytes per second or kbps, etc. Virtually all of them, and that's the motivation for considering something like get utilities, where...
Right, but like especially 1,000 separators?
Sorry?
Especially 1,000 separators, like where if you have 100,000 or something where it puts a comma in the middle.
Commas, no. Fortunately, no. Most utilities will be white space or tab separated so that an awk statement with the print and the dollar sign sort of step along there works just fine most of the time. So many of those you can just, they'll have headers, chop that off, grab the one you want, maybe grep for it or awk for it. Where it gets complicated is, I believe, let's just say the ZFS output. You have a long chart of all those items. Fortunately, they are generally uniquely named so you can find one. If you have ambiguous names, you have a problem. But fortunately, ZFS has included those kind of options to say, I want this only. So, other questions? Who would find this useful? Who would like help setting this up? Well, it's pretty simple, but in the course of this, it opens so many doors of questions to ask because they're very easy to answer. So the interaction of the packet filter and that kernel when dealing with a virtual machine. Well, okay, so when you hit walls, okay, who's to blame? Maybe this will simply show you, literally show you who's to blame. And Not PF. PF's never to blame. So it is 10 after, is it not? And I am until, well, thank you. Very Bhyve specific statistics collected and extracted. Now let's get down to this. For the host OS items, I only have one that I did time sample before and time sample after, which was the netstat iBytes output. And we're doing, again, simple math. We're making per second a little more human friendly. There's disagreement on how best to do that math, but it's very easy to change. So we are in, and after waiting, let's take a look at the sleep interval. So at the top of the screen, I read in a sleep interval just for the specific test. If you want to try it 1 per second just while testing, or once every 30 seconds to get a more accurate result. Some of those numbers out of Bhyve were very large, so I was chopping down from the millions down to, say, 4 digits. Fortunately, again, our no commas to deal with. And in action, let's run this. What's that? So I've entered a NIC. I don't know if I have a virtual machine running. Let me get the machine running. Okay, so network interface EM0, disk media 0. Sampling every 2 seconds, get that back running again. Okay, now we're booting virtual machine, and we get some more useful statistics. So, not sure what that one was, maybe it's not fully up. We have a human readable name, we have a simple metric sent, we have a Unix epoch timestamp, and just for the user, I have a little report on what's going on there. So, some human readable information on the side there. trying to bring up a web browser. I started Carbon on the host, and I started Graphite on the host. Try this on a microscopic screen there. Thumbs up? Okay, cool. Well, thank you. And again, I'll gladly sit down with anyone and run through some strategies.
Thank you very much.